A very good morning to Dr. Fung and my fellow friends. Today we are from Group 3, will be presenting Tutorial 11. Before we proceed to Tutorial 11, let me introduce you to Group 3 members, Hao Jenny, Kisha, Muhammad Abid Alal, Eng Shen Wei, and Tan Yan Ping. Today we will discuss 3 questions, Question 1, Question 2, and Question 3. Without further ado, we will proceed with Question 1. A town recently started a single-stream recycling program provided 60-gallon recycling bins to 13 randomly selected households and 75-gallon recycling bins to 11 randomly selected households. The total volume of recycling over a 10-week period was measured for each of the households. The average total volumes were 365 and 423 gallons for the households with the 60 and 75-gallon bins, respectively. The sample standard deviations were 52.5 and 43.8 gallons, respectively. Assume that the 10-week total volumes of recycling are approximately normally distributed. Using the 2% significance level, can you conclude that the variance for the 10-week recycling volume of all households having 60-gallon containers is different from the variance of all households that have 75-gallon containers? Without further ado, I will pass through Muhammad Abed to continue with the solution. Thank you.
Thank you, Kisha. I'm Muhammad Abdulal, and I'm going to review the answer for question 1. So, let S sub 1 square equal variance of all households having 60-gallon containers, and S sub 2 square equal variance of all households having 75-gallon containers. Step 1. Null and alternative hypothesis. Null hypothesis S sub 1 square equal S sub 2 square, and alternative hypothesis S sub 1 square not equal S sub 2 square. Step 2. Select the level of significant. The significant level is 0.02. Step 3. Select the test statistic. The appropriate test statistic to test a hypothesis of equal variance is F statistic. Moving on to the next step, step 4, decision rule. Reject H sub 0 if F greater than F over 2, variance 1 and variance 2. F greater than F 0.02 over 2, 13 minus 1 and 11 minus 1. F greater than F 0.01, 12, 10. F greater than 4.71. Next step, capturing the value of F and make a decision. F equal S sub 1 square over S sub 2 square, 52.5 square over 43.8 square, equal 1.437. Since the captured F value 1.437 is smaller than the critical value 4.71, we do not reject H sub 0. So we jump to the conclusion. The data indicates that there is no difference in the variance of having 60-gallon containers or 75-gallon containers. That's all for me. Thank you. I will pass to Yan Ping.
Thank you, Muhammad. I'm Yan Ping. So now let us continue with question 2. A student who has a 9 a.m. class on Monday, Wednesday, and Friday mornings wants to know if the mean time taken by students to find parking spaces just before 9 a.m. is the same for each of these 3 days of the week. He randomly selects 5 weeks and records the time taken to find a parking space on Monday, Wednesday, and Friday of each of these 5 weeks. These times in minutes are given in the following table. Assume that this student is representative of all students who need to find a parking space just before 9 a.m. on these 3 days. Using the 5% significance level, test the null hypothesis that the mean time taken to find a parking space just before 9 a.m. on Monday, Wednesday, and Friday is the same for all students. Now I would like to pass to Jenny for the explanation of this question.
Thank you, Yanping, for introducing question 2. I am Jenny, and I'm going to review the solution for question 2. There are 7 steps in total in order to solve this question. I will go through the steps one by one. Firstly, we need to state the null hypothesis and the alternate hypothesis. The null hypothesis is that the mean time taken to find a parking space just before 9 a.m. on Monday, Wednesday, and Friday is the same for all students. That means H sub 0 is mu sub 1 equals to mu sub 2 equals to mu sub 3. This is also the claim. What about alternate hypothesis? The alternate hypothesis is that the mean time taken to find a parking space just before 9 a.m. on Monday, Wednesday, and Friday for all students are not the same. This means H sub 1 is the mean time is not equal. In an alternative way, we can also think of the alternate hypothesis is at least 2 mean time are not equal. If the null hypothesis is not rejected, we conclude that there is no difference in the mean time taken to find a parking space just before 9 a.m. on Monday, Wednesday, and Friday. If it's rejected, we conclude that there is a difference in at least one pair of mean time, but at this point, we do not know which pair or how many pairs differ. Step 2. Select the level of significance. We selected the 0.05 significance level. Step 3. Determine the test statistic. ANOVA uses F distribution in performing the test. Step 4. Formulate the decision rule. To determine the decision rule, we need the critical value. We need to know the degrees of freedom in the numerator and the denominator. The degrees of freedom in the numerator equals the number of treatments, designated as k minus 1. The degrees of freedom in the denominator is the total number of observations, n, minus the number of treatments. For this problem, there are 3 treatments and a total of 15 observations. Therefore, degrees of freedom in the numerator is k minus 1 equals to 3 minus 1 equals to 2, whereas degrees of freedom in the denominator equals to n minus k equals to 15 minus 3 equals to 12. Next, we need to refer to the F distribution table and the 0.05 significance level. How to refer to the table? Move horizontally across the top of the page to 2 degrees of freedom in the numerator. Then, move down that column to the row with 12 degrees of freedom. The value at this intersection is 3.89. So, the decision rule is to reject if the computed value of f exceeds 3.89. What is the critical value? F sub a, comma in bracket, k minus 1, comma n minus k equals to f sub 0.05, comma 2, comma 12, and 3.89 is our critical value. Proceeding to step 5, compute the test value. A. Find the mean and variance of each sample. For mean, the formula is x bar equals to sum of x divided by n. For variance, equals to sum in bracket x minus x bar square divided by n minus 1. As you can see from the table, these are the data we got from the question. The mean for Monday is 11.4, Wednesday is 10.6, Friday is 5.4. Whereas for variance, for Monday is 12.8, Wednesday is 13.3, Friday is 10.3. After calculating mean and variance, we need to find the grand mean, or x bar sub gm, the mean of all values in the samples. The formula of grand mean is sum of x divided by n equals to 6 plus 12 plus 15 plus 14 plus 10 plus 9 plus 12 plus 5, plus 14, plus 13, plus 3, plus 2, plus 10, plus 7, plus 5, divided by 15 equals to 9.13. Next, find the between group variance, MSB. The formula of MSB is sum n sub I in bracket x bar minus x bar sub gm square divided by k minus 1 equals to 5 in bracket 11.4 minus 9.13 square plus 5 in bracket 10.6 minus 9.13 square plus 5 in bracket 5.4 minus 9.13 square divided by 3 minus 1 equals to 106.13 divided by 2 equals to 53.07. Next, find the within group variance, mean square error. The formula of MSE is sum in bracket n sub I minus 1 s sub I square divided by sum in bracket n sub I minus 1 equals to in bracket 5 minus 1 in bracket 12.8 plus in bracket 5 minus 1 in bracket 13.3 plus in bracket 5 minus 1 in bracket 10.3 divided by in bracket 5 minus 1 plus in bracket 5 minus 1 plus in bracket 5 minus 1 equals to 145.6 divided by 12 equals to 12.13. Next, find the f-test value. The f-test value is MSB divided by MSE equals to 53.07 divided by 12.13 equals to 4.375. After that, make a decision. The computed value of f is 4.375, which is greater than the critical value of 3.89, so the null hypothesis is rejected. Coming to the last step, summarize the results. We conclude that population means are not all equal. The mean time taken to find a parking space just before 9 a.m. on Monday, Wednesday, and Friday are not the same. It is likely that the time taken to find a parking space is related to the particular day. At this point, we can only conclude there is a difference in the treatment means. We cannot determine which treatment groups differ or how many treatment groups differ. That's all for my part. Now, I will pass to Yanping to introduce question 3.
Thank you, Jenny, for the explanation. Let us proceed with the question 3 now. A small college town has 4 pizza parlors that make deliveries. A student doing a research paper for her business management class decides to compare how promptly the 4 parlors deliver. On 6 randomly chosen nights, she orders a large pepperoni pizza from each establishment, then records the elapsed time until the pizza is delivered to her apartment. Assume that her apartment is approximately the same distance from the 4 pizza parlors. The following table shows the times in minutes for these deliveries. Using a 5% significance level, test the null hypothesis that the mean delivery time is the same for each of the 4 pizza parlors. So for the answer of question 3, I would like to pass to Shenwei now to let her explain about it.
Thank you, Yanping. I'm Shenwei. I will proceed with the solution of question 3. So there are 5 steps to solve this question. Step 1. State the null and alternative hypothesis. The null hypothesis is mean 1 equals to mean 2 equals to mean 3 equals to mean 4, while the alternative hypothesis is at least one mean is different from the others. Step 2. Find the critical value. The level of significance is given from the question, which is 0.05. And then we find the critical value. Since k equals to 4 and n equals to 24, the degrees of freedom in numerator is k minus 1, which is 4 minus 1 equals to 3, while the degrees of freedom in the denominator is n minus k, which is 24 minus 4 equals to 20. And then we refer to the F distribution table. We will get the critical value is 3.10. We will reject the null hypothesis if the test statistics value is greater than the critical value. Otherwise, we do not reject it. Next, we proceed to step 3. Compute the test value using the procedure outlined here. A. Find the mean and the variance of each sample. So for mean, the formula is x bar equals to sum of x divided by n. While for variance, the formula is sum in bracket x minus x bar square divided by n minus 1. And then the table below shows the data from the question and the mean and variance that we calculate. So the mean for Tony's is 20.68, mean for Luigi is 25.35, mean for Angelos is 26.03, and mean for Kowalski is 25.33. The variance for Tony is 4.35, variance for Luigi is 16.95, variance for Angelos is 7.71, and the last variance for Kowalski is 3.73. Next, B. Find the grand mean, the mean of all values in the samples. The formula for grand mean is sum of x divided by n equals to 20 plus 24 plus 18.3 plus 22 plus 20.8 plus 19 plus 22.1 plus 27 plus 20.2 plus 32 plus 26 plus 24.8 plus 22.3 plus 26 plus 24 plus 30.1 plus 28 plus 25.8 plus 23.9 plus 24.1 plus 25.8 plus 29 plus 25 plus 24.2 divided by 24, and we will get 584.4 divided by 24, and then we'll get the final answer 24.35. C. Find the between group variance MSB. The formula for MSB is sum n sub I in bracket sample mean minus grain mean square divided by k minus 1 equals to 6 in bracket 20.68 minus 24.35 square plus 6 in bracket 25.35 minus 24.35 square plus 6 in bracket 26.03 minus 24.35 square plus 6 in bracket 25.33 minus 24.35 square divided by 4 minus 1. We will get 109.5102 divided by 3. And then we'll get the answer 36.5034. We proceed to D. Find the within group variance MSE. The formula for MSE is sum in bracket n sub I minus 1 s sub I square divided by sum in bracket n sub I minus 1, which is 6 minus 1 times 4.35 plus 6 minus 1 times 16.95 plus 6 minus 1 times 7.71 plus 6 minus 1 times 3.73 divided by 6 minus 1 plus 6 minus 1 plus 6 minus 1 plus 6 minus 1. And then we will get 163.7 divided by 20. We will get the answer 8.185. And then E. Find the F-test value. The formula of finding F-test value is MSB divided by MSE, which is 36.5034 divided by 8.185, and then we'll get the F 4.46. Step 4. Make decision. Since the computed value of F is 4.46, which is greater than the critical value 3.10, so we reject the null hypothesis. We proceed to the last step, step 5. Make conclusion. At the significance level of 5%, there is sufficient evidence to reject the claim and conclude that at least one mean delivery time is different from other pizza parlors. That's all from me. Thank you. That's all from us. Thank you for listening and have a nice day.